Databases are essential tools for data analysts. I use them constantly. Just about all of the data I access is stored within databases. Databases store and organize data, making it much easier for data analysts to manage and access information. They help us get insights faster, make data-driven decisions, and solve problems. You've already heard a bit about what databases are and how they're used by data analysts. Now, let's learn more about database features and components. As you've learned, a database is a collection of data stored in a computer system. Here's a simple database structure. It contains tables with information from a car manufacturer. The top level includes car dealerships, product details, and repair parts. Then, if you drill down to the next level by selecting one of those tables, you'll find more specific details about each item. This is called a relational database. A relational database is a database that contains a series of tables that can be connected to form relationships. For two tables to have a relationship, one or more of the same fields must exist inside both tables. For example, here, branch ID exists in this table and this one. If a field exists within both tables, we can use it to connect the tables together. Certain fields can also be referred to as a primary key. A primary key is an identifier that references a column in which each value is unique. So in our car manufacturer example, we can see that branch ID is the primary key in the dealership table, VIN is the primary key in the product details table, and part ID is the primary key in the repair parts table. Primary keys are unique and can only exist once within a given table. There's also foreign keys. A foreign key is a field within a table that's a primary key in another table. So in our example, the VIN is the foreign key in the repair parts table. As you can see, a table can only have one primary key, but it can have multiple foreign keys. Relational databases are great for keeping data consistent, no matter where it's accessed. Mobile banking is an interesting example of this. Let's say you deposit a check into your bank account using your mobile banking app. Then you check your account balance on your computer. The database relationship makes sure that the deposit shows up immediately on both platforms. Or let's say you work on a team of data analysts located in different offices. Relational databases make sure everyone's looking at the exact same data and can collaborate using a single set of accurate information. Now let's explore some different types of relational databases. First, a normalized database is a database in which only related data is stored in each table. The main idea behind database normalization is that a table should be about a specific topic and only include supporting related data. This is important because it minimizes the chances of having redundancies. A redundancy occurs when the same piece of data is stored in two or more separate places. Redundancies waste time and space in your database. For example, if you needed to change a piece of data in a database with redundancies, you'd have to make the same update in every place where the data exists. That would take a lot of time and could easily lead to typos or other errors. Next up, we have schemas. A schema is a way of describing the way something is organized. You can think about data schemas like blueprints of how the database is constructed. Schemas are useful when you're learning about a new data set or designing a relational database. You'll learn more about different types of schemas in an upcoming reading. All right, you've learned a lot about databases and how data analysts use them to gain important insights every day. Soon you'll begin practicing how to access and analyze data from actual databases. That will be a great opportunity to improve your understanding of database organization, the benefits of each method, and how you might use databases in your future analytics career.